Okay, so I wanted to create a new video on Certified Kubernetes Security Specialist. I've got a little bit of custom scenario. I've blogged about this previously, so if you haven't seen the blog, I'll put that in the description. But at a high level, I just wanted to break down why the scenario exercises the important nature of auto-mounting your service tokens. But just to give you a high-level view of what are some of the best practices when you are deploying objects with a auto-mount service account token attached to it. So for the scenario, I deploy through my specific bash script CKS training namespace with 3 separate pods. Those 3 separate pods will have either the default service account that's attached with the pod at creation, or if you have the specific syntax, which we'll see for the secure pod, it won't attach the underlying service account that can read secrets and inadvertently be accessed. So the purpose of this is to describe at a high level auto mount service account token, and we'll look how you actually disable this to false from that perspective. Now broadly, we're also going to see a inadvertent access to our secrets, and I don't want to spoil it, so I just wanted to walk you through what that really looks like. So let me switch over to my cluster. So if you see here inside this, and I'll zoom this in for a little bit. Okay, so you should be seeing, let me run and kubectl get nodes. This is just a plain vanilla cluster that we have here. Now you'll see that I have my control plane, my nodes 1. Now I've already cloned the repository, so I've already ran earlier a git command for the repository here. And inside of the specific scenarios, I have scenario 1. And you'll see I have scenario and then validation. I've already changed those to an executable. So now I'll just run a specific scenario.sh. And this will create everything for you in the back end. So a lot of text here, so I'll walk you through what's going on. So we talked about first the namespace being created. Think of this as the segmentation of where our pods are going to live at, and then 3 specific service accounts. And we'll look at what that looks like. And then we also have a secret that's been created, a role binding for a specific role named secrets reader, and then the role binding for read secrets, a part of that. And then along with that, we've attached the 3 pods from that perspective. So this specific syntax is to guide you through how to access the underlying pod through a shell, and then check if you can actually verify that the token's been mounted from those, okay? Now, the idea for this is to run a validation script after you complete this task. In real time, we are essentially asked to place any of the access password and API key that is decoded into a temp exercise completed. So first, at a high level, let's back up and let's look at our namespace. So if we go kubectl get namespace, we can see we have CKS training. So now we can look at further what is a part of that. So we have the 3 pods as spoken about. So now if I do, I'll put YAML grep auto mount. We can see the specific pods. This is running the command of getting all 3 pods in that namespace and the YAML format. And then we're running a grep command to look for the automountServiceAccount token. So we can see we have 2 values returned, right? We have one that's true and one that's false. Now we can also see the annotations explicit insecure and then the secure pod with that annotation false. Now broadly, when we're thinking about, okay, what is the purpose of this? You want to think about for the explicit insecure, how can we actually access the specific service account token? Now that we're aware that this specific service account token is valued as true, we can see if there's any existence on that end for the token itself, if we can access that token. So let's clear this out and let's look into running the following. So we're going to run a shell into our explicit insecure pod. And we also got to annotate the namespace it resides in, right? And now we're going to run a specific LSLA. And we should see secrets. Let me split that up. Kubernetes.io service account. So we can see from this visual, from this list command of that specific directory, that we have a token, right? So this is right here. So now if we run that same command, and instead we try to take a look at that token, we're going to see if we can access that from there. Now you'll see the difference when I run this against the secure pod as well, so I don't want to spoil anything, but just so you're aware how this would operate. So now we're in the shell, right? So if I run a simple who am I, we should get a return back root, okay, as well as set as root, so we should have some user context defined. That's another lesson, not for today. So now I can run cd var, and let's look at our run. So let's go back to secrets directory, cd kubernetes.io service account. And if I run an ls, then we can see token, right? Obviously token is not a directory, so I just wanted to show that. So now we get our specific token, right? Now, the token itself, we have to remember that this token is our access token. So then now we can use this access token if we wrap this in the process of kube token. We can run a kube token, we can run a cat, right? In the var run secrets kubernetes.io and then service account and our token. Now we can use this for a call to our cluster secrets. Now, before we go a little bit further, it's also important to know where the secrets are at. And so let me just paraphrase. Let me get out of here and I'll come back to that. So let me run this. So we know we have secrets defined in every cluster. So let's see if we have what secrets we have here. So we have a secret known as sensitive data, and we have the type opaque, and then it looks like 2 values from that perspective. Now, obviously, to not spoil it, I wouldn't just access this inadvertently without the ability to read those specific secrets, right? I'm obviously the cluster admin, so I have that privilege to read, write from that perspective. Now we're thinking about this from the outsider perspective, right? If the pod itself has a specific service account that can read those secrets and that pod is compromised and those secrets are sensitive in nature, those are the things we want to worry about. So if we go back to our shell, just to show you what that would look like, so we can do the echo kube token just to make sure that's still set. Okay, it looks like that's not, so let me run that back one more time. Secrets, and we'll do kubernetes.io service account token. Uh-oh, where did I go wrong here? Oh, that's simple. I didn't put my $sign here. Uh-oh. Okay, so var run secrets, Let me see if I type something wrong here. Oh, I didn't space out my cat command, so that is an issue. Okay, so now we'll format the API call. So to call the API using our token as a bearer, we're going to use our default service. We're going to call our API v1, and we have to specify the namespace. So we know we're in CKS training from what we've deployed, and we know we're trying to access the secret. So now if I hit a backslash, space H, authorization, bearer, and now we put our kube token. Let's wrap that right there. And so we'll get a specific secrets are forbidden, right? Cannot list that specifically. Now, remember this was the explicit insecure. And even though it does have the auto mount specifically true, doesn't mean directly that we can't access that, but we can access it this way, okay? Now, we're gonna look at what's the difference between this and the insecure. Okay, so now that's just demonstrate, okay, now we've hit a roadblock, no worries. Okay, so now we do get pods and CKS training. And let's look at the YAML manifest of insecure pod, okay? We'll run. Okay, so we can see we have our volume mount, right? So this is that service account right here. We can look up a little bit. We have our insecure CA, or service account from that perspective, attached to this. So now let's just run a kube describe. What I like to do as well is for reconnaissance purposes, let's look at the specific service accounts inside the namespace. If you do a kube describe service accounts in the namespace, this should give us an output. So, okay, kube describe CKS training. So now we can see here, we have three, well, we have our default, our explicit insecure, and then our insecure SA. So now if we get our roles in CKS training, describe secret reader. Now you also have to annotate the API group, essentially the role itself, right? Don't forget that if you're trying to, you have to be speedy with these terminals. Okay, so we can see it has a get and list of the secrets, right? So anything associated with that secrets reader. So now we can get role bindings in CKS training. Okay, describe our role binding. So this is already deployed for you with the first script. The reason I'm going through this a little bit slower is so you understand the nuance with this, okay? So now we run a describe that role binding. And now we can see that this specific role can read our secrets, it can list them, and it is tied to our insecure service account, okay? So these are the only roles that we see that are associated with our CKS training with the role binding, okay? Now, if we take a step back, now we can perform the same manner, execute in our insecure pod. And what we're going to do is try the similar fashion of looking for that same token. And knowing that we have access to that token specifically, we're going to ensure that that token is accessible, right? So we're going to do run secrets, same thing. Oh, I forgot to add the namespace. Okay, so we'll see that that token's there. We'll perform the same operation where we're going to shell into our specific insecure pod, and then we're going to get that token, wrap that in a kube token, and then issue the same call and see if we can access that. Now remember, we have to ensure that we have the specific secrets decoded, and then those have to be saved for the validation script to work, okay? So now if I hit our shell, and I can run the same kube token. Service account, account. And if we put our token specifically, right? Let me pause. Okay, so what I realized is I did not add the v1 to that. So don't be like me and add the v1 in between API and namespaces. That obviously would return an error, as it would not validate that specific statement, essentially an access rejected. So now we can see that we have access to our API key. So if you see, we use that token that is mounted from our role binding that is associated with the service account. We've executed inside the insecure pod. We've grabbed that token in a variable, wrapped that, and then made an API call to the secrets to retrieve that specifically. Now remember, this is using that service account get and list command from that role binding associated with that service account. So because of that, we have full access now. Remember, we have to base, and base 64 is the encoded secret. Now we have to decode that to get our actual specific code itself, but fairly simple. We are still in our shell. We're going to make our directory exercise completed. Okay, and then now we're going to echo our specific syntax here. And we're going to pipe that into base 64, decode that, and then we're going to put that in our temp exercise completed, and we're going to call that first one our API key.txt. And we're going to do the same thing with the next one. We're just going to change that to password, similar to that. And let's go back and pipe that in. And we should then run our validation script, and we'll see if that satisfies it. And that should be the challenge complete. Okay, so then now let's get out of here. Cast scenarios. Validate sh. Okay, so it's going to start the validation. Found the required namespace and pod, check if you completed, verified you decoded the secrets correctly. So now to get rid of the pod itself, ideally this is to demonstrate why you need to be cognizant of when you do use the auto mount, what are the underlying service accounts, and what are the permissions that those service accounts have if those were compromised in any shape or form. But broadly, this is just to get you familiarized with understanding, okay, now we have an issue, how can we find it quickly? And then ideally, if you want to break all this down, you can just run kubectl delete pods and CKS training, or just delete the namespace completely. Okay, so hopefully that helps solidify for this specific scenario. I just wanted to make a quick video. I know I had some hiccups there, but hopefully that helps with that specific scenario, and I will be making more of these as time progresses just to help out those who are trying to understand Kubernetes security. Validate sh. Okay, so it's going to start the validation. Found the required namespace and pod, check if you completed.